Okay, hello everyone. I welcomes to all in our lecture series on fiber optics. In this lecture series, we are discussing these topics, which are most essential for B.sc, B.Tech, M.sc, M.Tech, and various entrance examinations. Last class we discussed losses in optical fiber and corresponding numerical. In this class, we are going to discuss different mechanism of attenuation and applications of fiber optics. Okay, so let us start. Here, there are several loss mechanisms responsible for attenuation in optical fibers. They are broadly classified into two categories: intrinsic and extrinsic attenuation. First, we are going to discuss intrinsic, then we are going to go for extrinsic attenuation. Intrinsic attenuation caused by the impurities present in the glass. Here, glass means the core. We know a optical fiber made up of core and clad. Clad is the outer part. So inner part is your core and outer part is your clad. Okay, the light signal propagating through the fiber means propagating through the core part. If a impurity will be present in the core, then that impurity will cause the attenuation. Here same thing it has been written. During manufacturing, it is very difficult to eliminate all the impurities. When a light signal hits an impurity in the fiber, either it is scattered or it is absorbed. Either scattered or absorbed, the attenuation will happen inside the core or inside the fiber. Intrinsic attenuation can be further characterized or classified by two components. One is your material absorption and another is your religion scattering. Material absorption occurs as a result of imperfection and impurities in the fiber, accounts around only 3 to 5 percentage. So material absorption responsible for only 3 to 5 percentage of attenuation. Rest around 96 percentage attenuation happens due to Rayleigh scattering. Here 3 to 5% happens due to material absorption. Okay, the most of common impurity in is your hydroxyl molecule. So at the time of manufacturing the glass or core, hydroxyl molecule will be present inside the core, and this causes the absorption, due to which we can get 3 to 5% attenuation in the optical fiber. Now we are going to go for Rayleigh scattering. Rayleigh scattering responsible for the majority of attenuation in optical fiber, around 96 percentage. How it happens? The local microscopic density variation in the glass cause local variation of refractive index. This variation, which are inherent in the manufacturing process and cannot be eliminated, could not be eliminated, which act as obstruction and scatter light in all the directions. This known as Rayleigh scattering. Here you can see, suppose this is your optical fiber or this is your core part. Okay, so here the light signal propagating through this optical fiber from this end to this end. So due to the refractive index variation from one place to another place, suppose in between these 2 points there is some refractive index variation. That means suppose this portion has refractive index is larger, this portion suppose, and this portion refractive index is less, this portion is high. High refractive index means denser or density is large. Density means atoms or molecules per unit volume is large as compared to this area. So if atoms and molecules will be large in this area, that means scattering probability will be increased. These are the scattered waves, which waves could not be moved through the optical fiber. Due to that, we can get the attenuation, right? So this is all about your Rayleigh scattering, and this happens how? Due to the variation of refractive index, and this happens at the time of manufacturing. Okay, the Rayleigh scattering loss greatly depends upon the wavelength. This is very important expression. So Rayleigh scattering is proportional to 1 by lambda to the power 4. So if lambda will increase, scattering will be less. That means suppose I am going to consider red light and blue light. Okay, so red light wavelength is larger than the blue light. So here blue light will more scattered because Rayleigh scattering is inverse proportional to wavelength. So here for the blue uh, light, wavelength is less, so blue light will scatter more as compared with red light. Okay, so this is in short about intrinsic attenuation in the optical fiber. Now we are going to discuss the extrinsic attenuation or bending losses. Here extrinsic attenuation is caused by two external mechanisms. First is your macro bending and micro bending. Both of them causes a reduction of optical power or the so-called attenuation in the fiber. If a bend is imposed on a optical fiber, strain is placed on the fiber along the region that it is bent. So if I'm going to consider this is the optical fiber, here at this point it is bent. So here at this point of the fiber, strain is increased on the fiber. Okay, the bending strain affects the refractive index. So due to this bend, here refractive index could not be uniform as we are going to consider this side. So here refractive index will be slightly changed due to bending. If refractive index will change, then the ray which is propagating through the optical fiber with the help of internal reflection, at this point that ray will found uh, a significant change of refractive index. So the condition of internal reflection could not be satisfied due to the change of refractive index. So internal reflection could not be happen exactly in this region. So few of light will be refracted through clad. As the result, we can get the attenuation in the optical fiber. Same thing it has been written. The bending strain affect the refractive index and critical angle of the light ray in that specific area. As the result, the condition of total internal reflection is no longer satisfied. Hence, the light travels in core can refracted out and losses occur. Refracted, I told that refracted through the clad. And this bending can be two types: macro bend loss and micro bend loss. Here macro bend means can be visible. If the fiber bends like this, it can be visible by naked eyes. Okay, anyone can visualize that fiber is bends like this. Here a macro bend is a large scale bend that is visible. When a fiber is bent through a large angle, strain is placed on the fiber along the region that is bent. So here strain, significant strain will be produced, due to which it changes the refractive index, due to which internal reflection condition could not be satisfied, what we discussed. Now uh, if I'm going to consider micro bend loss, micro bend loss is a slightly bend at the edges of the core. Here micro bend, it could not be visualized by naked eye. It is a small scale distortion like this, small scale distortion in the at the edge of the fiber. Okay, it is localized and generally inductive of pressure on the fiber. So here in this region pressure will be increases. Micro bending might be related to temperature, tensile stress or crossing force. So due to these effect, this micro bend can be expected inside the fiber. Due to this micro bend, the light ray scattered at this point, at these points. So wherever we have micro bend, there scattered happens, due to which we can found attenuation in optical fiber. Okay, so this is all about your different mechanisms of attenuation. If this question will be asked in your exam, it will ask for 2 to 3 mark. So you have to write the main points whatever we discussed in the class. Okay, and these are the important applications of fibers. Here no degradation of signal, that means less attenuation we can found as compared to the conventional copper wire. Low dispersion makes the fiber suitable for use. High data rate, single mode fiber gives higher transmission rate, up to 550 times more distance than multimode. Used as underwater cables. Here multimode step index are relatively easy to manufacture and is less expensive. LED or laser source can be used. Launching of light into fiber is easier. It is easier to couple multimode fiber with other fibers. Either an LED or laser can be used as source of light in graded index fibers. it is used in telephone links, used waveguides in telecommunication, used in fabrication new family of sensors, and many more. Here I represented few applications. You can refer some other books or some other source to found other applications of fiber optics. Okay, this is all about your different mechanisms of attenuation and application of fibers. Thank you so much for watching this video. Thank you.